Good morning, everybody. I know it's been a long time since I've made any sort of videos, and honestly it will probably be a little while before I make any other videos, but I've been on YouTube for a while, been seeing this argument go around and around, and it seems like there's been no progress on the argument, so I thought I'd shed my perspective on what I see is wrong with this cosmological argument, and why I think this is the best way to approach it. So first of all, if you don't know what the cosmological argument is, the one I'll be arguing against goes like this. Everything that has a beginning of its existence has a cause for its existence. The universe had a beginning of its existence, and therefore the universe has a cause, and then people usually go on to say that cause is some sort of deity. Now I take issue with the second part, which says the universe has a beginning of its existence. Now there have been other atheists who have normally argued that, okay, well, the beginning is uncaused because you can have causes that aren't causal or something like that. Like you can have things that spring into existence from nothing into something. And I don't take that approach. I think that's not the approach one actually needs to take. I think the defensive part should be on the person who is trying to use the cosmological argument for the following reason. When people normally bring this up, they say, well, look, the Big Bang says we started out here, or we started in the singularity, and then we expanded outwards. And so there was the singularity, and they say the singularity is this infinite point, it's nothingness, and then poof, things became something. Well, that's simply not what physics is actually telling us. So when you get that Big Bang singularity, that's the result of general relativity. And general relativity is a great theory, predicts a lot of things accurately, but it also gets a lot of things incorrect. And this is why we need quantum mechanics. Let me get a quote from a paper I pulled off of the archive document. I'm going to link all of these documents in the description of the video. So the quote goes, "It is folk wisdom that singularities and divergences are not really physical, but rather technical artifacts indicating the limitations of the theory in which they appear." That is basically telling us in physics, when we get to singularities, when we get to infinite quantities, and we can't normalize them, we can't get rid of them, we can't resolve them, that's telling us that our theory is incomplete. And as an example of this, if we go back to the early 1900s, we had something called the ultraviolet catastrophe. And in classical physics, this is a prediction of classical physics that told us if we looked at a black body, this certain type of object, it would emit infinite radiation. We'd have an infinite amount of radiation coming off this thing. And that was a prediction of classical physics. And we didn't just say, well, okay, well, classical physics predict this. First of all, in this case, it was easy because we could test it. We could say, well, look, there's not infinite energy coming off of this black body, so something must be wrong here. And what happened was that we ended up quantizing the energy, and this resolved our problem. There's more details than that, but I won't go into them in this video. If you'd like to know more, let me know. So this idea of a singularity is a similar issue. We're going to have infinite energy at the Big Bang singularity, and the same problems are going to arise. And we know this is where our laws are breaking down. General relativity cannot accurately, or with any power, predict a singularity because we know at that point the theory doesn't work. We're applying it to where it doesn't belong. The same issue was with the classical ultraviolet catastrophe. We applied classical physics to an era, or to an area, where we needed to include quantum correction. And the same thing is true of general relativity in this case. So we need a theory of quantum gravity. You notice we have 4 fundamental forces in our universe. 3 of them have been combined with quantum mechanics pretty well, and the one that's left is gravity. So if we take a look at some tentative theories of quantum gravity, things that these aren't agreed upon yet, and there are multiple ones, but they're progress in the field. So let's take a look at what these ideas of quantum gravity are telling us right now. Well, even though they are very different, we have loop quantum gravity on one hand, and then we have string theory on the other. And I'm guessing most of you have heard of string theory just because of Brian Greene's TV show he did a while back. That's pretty much how I learned about it. And the other one, loop quantum gravity, is not as well known, but still a very important contender in the argument, in the theories for quantum gravity. So what do they say about singularities? Well, they tend to resolve all singularities. And if they aren't resolvable, that's telling the theorist that they need to do more work. And they resolve them in different ways because the structure of these theories are different, but the overall notion is that they do resolve singularities. They get rid of them, And we know singularities aren't a physical thing. They're not supposed to be there. That's when we know we've got the error. So I guess the point I want to bring home is that general relativity makes a prediction for a singularity. Okay. We know when it makes that prediction, there's a problem. That singularity should not exist. We should not get the singularity. It's telling us, that's a way of saying, hey, there's an error in the calculation, there's a problem. And normally we can fix certain singularities, but ones like the Big Bang singularity we haven't been able to resolve with general relativity. And that's just telling us our theory is incomplete. We need to do more. And we know this. We know that we need to get a quantum explanation for gravity. We have a quantum explanation for the other three forces, but right now gravity is either relativity or nothing. There's no quantum addition, and we need to include that. And so to rely on the Big Bang as an argument for the beginning of the universe because, well, the Big Bang says there's a singularity and then that doesn't make any sense. We don't have the singularity. It isn't there. And I can just finish up here and end my argument by a quote that I got in another paper. It says, quantum physics does not stop at the Big Bang. The classical space-time dissolves near the Big Bang, but the spin network is still there. This is a loop quantum gravity. It is, to a certain extent, eternal. There was thus no emergence of the universe from nothing, because nothing simply does not exist. There was always something already. So, hope you take that argument into account, and I think this really takes the feet out of the argument, kind of knocks it over, because there's really no reason to posit the universe has a cause, because there's no reason to think it does. In fact, what physics seems to be pointing to is that there can be no such thing as nothing. There's no nothingness, whatever that could conceivably be. We always have something. If we have something now, there's no way to go back and to take space and get rid of it, to have it disappear. And since we have it now, logically it must have existed at all points prior. There's no singularities that should exist, and therefore we don't have an issue. And the Big Bang doesn't even predict a singularity, because the prediction is made by a theory which is no longer valid in that scheme. So again, hope this argument helps. If you have any questions about it, let me know. If you think I'm totally wrong, let me know. It'll be a fun discussion. Thanks.